This video will introduce how to use output execution logic. Open the agent character blueprint and locate the myArmy decision array. Add an element to this array. The myArmy decision array is divided into the decision input conditional input array and the decision output execution logic output array. Add a new element to the output array and implement the logic as shown in the video to make the character move forward. Fill in the question mark with the desired movement speed. Return to the level and place the agents in the scene. Before starting the simulation, we need to select and check some key parameters in the myArmy global node. myArmy global frame, this parameter defines the length of the frame to be computed. Make sure that the myArmy global widget variable is set to the myArmy widget blueprint state. Click the Run Simulation button. Since the global settings haven't enabled myArmy Begin Play to auto-simulate, we'll need to press the M key to start the simulation. You can try checking the myArmy Begin Play option to enable auto-simulation, so when you click the Run Simulation button, it will run the simulation alongside the game directly. Clear the randomly placed agents from the placement node. Here, we'll need just a single agent for the logic demonstration. Place the agents again, run the simulation, and observe the result of the logic execution. Go back to the agent blueprint and add logic for a leftward rotation. Set the rotation strength to 1 in place of the question mark. Run the simulation to observe the result of the left rotation. Add the logic for playing an animation and replace question mark with the name of the animation montage segment you want your agent to play, notice not the animation sequence name. Run the simulation to observe the result of the playing the specified animation montage segment logic. For better workflow, add a new logic element, move the animation playback logic to this element, and then add the logic for random animation playback rate. Run the simulation to watch the result, which now includes random animation playback speed. Add another logic element, and fill in the match terrain logic to its output. Run the simulation again to watch it. The newly added logic drives the agents matching the ground. Next, let me show you how to use rigid body physics and work on the terrain. First, delete the terrain matching logic. Then, select the global node and enable self-gravity by checking My Army Self-Gravity. Replace the agents to ensure the parameters are updated in agent memory. Run the simulation and watch the result. Next, let's replace it with a pre-built My Army agent blueprint that has physical setup, to demonstrate the effects of physics simulation. Open the agent character blueprint and add logic to run the dynamical simulation. Before enabling physics simulation logic, ensure that the skeleton mesh contains and is properly set up correctly for physical simulation. Place the agents and run the simulation to watch the result of the physical simulation effects.